Hello everyone and welcome back. My name is Mr. Koval, and in this video we're going to continue with periodic trends and we're going to talk about reactivity. So let's get into this. So once again, when we're thinking about the trend, we're thinking about, okay, atomic size, we're thinking about effective nuclear charge, things like that. So let's recap. So when we're looking at the effective nuclear charge, so these red numbers are the effective nuclear charge of the nucleus on the valence electrons, and we're looking at the size. You can see as you go down a group, the atom gets bigger, the valence electrons are getting farther away because you're adding more energy levels, right? So, okay, so let's look at reactivity. When we mean reactivity, we're talking about how they're reacting with other atoms. So, in order to react, electrons are losing or gaining valence electrons in order to become stable, like the noble gas. So, when we're talking about noble gases, one thing I should say is that things like reactivity or electronegativity or things like that don't really apply to noble gases, because noble gases are stable, so they're not going to want electrons, they're not going to give electrons, they're not going to take electrons, so they're not going to be reactive. So the noble gases over on the right side of the table really don't apply these trends. These trends don't apply to them. Electro ionization energy would still apply. Atomic size would still apply, but things like reactivity or electronegativity don't apply to the noble gases. So when we're looking at reactivity, we understand that elements in the same group have similar types of behavior because they have the same the same valence electrons. So we know that the number of valence electrons of an atom corresponds to the group number. So if you're in group number 5, you'll have 5 valence electrons. 1, 2, 3, 4, 5. And then this one over here, 1, 2, 3, 4, 5. So they're in the same group. These two are in the same group. So they're in group 4. So they have 4 valence electrons. They have 4 valence electrons. And so keeping that in mind, because of that, because the number of valence electrons is what determines the reactivity that you're going to be undergoing, whether you're going to lose or gain electrons, then we would expect that atoms in the same group and having the same valence electrons are going to have similar reactivities, similar properties. However, the magnitude of their reactions changes. And so what we want to keep in mind when we're thinking about the trend in reactivity is, do they want to lose or do they want to gain electrons, right? So remember about metals and nonmetals. The difference between metals and nonmetals is that metals, in order to be like the noble gas, they want to get rid of their electrons. They want to get rid of them because that's how they're going to get that full outer shell. Nonmetals, on the other hand, they don't want to lose electrons. They want to gain them in order to get that full outer shell. And so, keeping that in mind, we can figure out what the trend is and what we would expect. So when we're thinking about metals, so on this side we got metals. So because the metals want to lose electrons, the easier to remove that electron, the more reactive it would be. So if reactivity is how badly, how quickly, or how strongly it wants to get rid or take an electron, then for metals, we're looking at how easily it can get rid of that electron. And what we said before, so as we're going down a group, we could see that we're adding an energy level. So the valence electron is getting farther away from the nucleus, the positively charged nucleus, and it's the positively charged nucleus that's attracting the electron. And as we said, the farther the distance, the weaker the attractive force. And therefore, the easier it is to remove that electron. So if we're thinking that if the ease of removing an electron is going to be more reactive, then we would expect as you go down a group for your metals, the reactivity is going to get stronger. So it's going to become more reactive. Why? Because it's going to be easier to remove the electron when it reacts. So it's, if it's easier to remove the electron, it's going to react more quickly, more easily, more strongly, right? So when we're up here where the nucleus is closer, the electron is closer to the nucleus, stronger attractive force, so therefore harder to remove the electron, and it's not going to react as easily. If we're understanding reaction or reactivity as how easily the metal can lose that electron. So the more easily it can remove that electron, the more reactive it's going to be. So we would expect the reactivity of metals to increase going down the group. Well, what about nonmetals? Well, nonmetals have the opposite problem. I shouldn't say problem, but they have the opposite effect. So nonmetals want electrons. They don't want to lose electrons. So the more easily or more strongly that an atom can gain that electron or pull on that electron, the more easily it will get that electron and hold on to it. And therefore, when we're talking about nonmetals, we're thinking about how easily those nonmetal atoms can gain the electrons or attract those electrons more strongly. And so here we're looking at, again, how strong the attractive forces are. And again, we're looking at, in a group, the effective nuclear charge is the same, so that's not really going to be a factor in this one. So we're looking at size again. This time we'll notice that, again, because the atom is larger here, and so the valence electrons are farther away, the nucleus is not attracting them as strongly towards the nucleus because they are farther away, and so the attractive force is weaker. But if you go up in the group, the attractive force is stronger because the atoms are closer. So, and we also have more protons going this way. So if you're going this way here, we're gaining more protons. We're going to have more attractive force. But when we're looking at these two, right, this one is going to have a more strongly attractive force because the atom is smaller, the electrons are closer. So to gain that extra electron in order to react and create a bond of some sort or get that electron, this is going to be more easily attracted to the electron. So the electron is going to be more easily added to this atom than it is to this atom. And so if we're looking at group number six, the electrons are going to be more easily attracted to this atom. So an electron coming into this atom, it's going to be more strongly pulled in, and so this is going to be a stronger reaction. Whereas for this one, the energy level is farther away. The electrons here are not pulled as strongly, and so an electron coming in here is not going to be pulled as strongly, and so this one is not going to be as reactive. So with that in mind, we can understand why the nonmetals, their reactivity increases going up the group. So going up a group, reactivity increases for the nonmetals. Going down a group, the reactivity increases for your metals. So they're opposites of each other for that reason. So I hope this makes sense. I hope you learned something from this. If this was an interesting video and you got something out of it, please like my video, hit that like button, subscribe to my channel, hit that notification bell, put a comment in the comment section. Let me know what you think. If you have any questions, I love to answer questions. So thanks for joining me. Have a great day.